Alrighty, so in example 4, we're asked to prove that our G is not one-to-one. Okay, so again, we can use these if-then statements. These if-then statements are the definition of one-to-one. So we start with the if, and if we get to the then, that means that it is one-to-one. But if we start with the if and we don't get a then, that means that it's not one-to-one. So essentially, what we need to do is, because we know we're trying to disprove it, we need to think of a counter example, basically. So we need to think about our function. So it's x squared. So what do squareds do? We know that squareds make everything positive, right? So that means if we have a 2 squared, that's 4. But if we have a negative 2 squared, that's also 4. So that's going to come in handy. So we're going to use this first one. Again, remember, we always start with the if, okay? And then our goal this time is not the then. Our goal is the opposite of the then because it says it's not one-to-one. So if we're starting with this if, which is A does not equal B, then our goal is to say f of A does equal f of B. Okay, so you switch it because we don't want it to be true. So again, let's think of two numbers, A and B, that are different. But when we plug them in, we get the same answer. So I actually just gave you guys an example. So we can say A is equal to 2 and B is equal to negative 2. Right? So A and B in this case are not equal, but when we plug them in over here, f of 2 and f of negative 2, oh, sorry, we're not actually working with f. These are g's. G's. Our function is a g, right? Alright, so when we plug this into our g, we actually get 2 squared, which is 4, and we get negative 2 squared, which is also 4. So that's how we prove that it's not one-to-one. Okay, another way that we can prove that it's not one-to-one is back on this board. I've actually added another thing down here. So it's not one-to-one if it touches a horizontal line more than once. So this is the horizontal line test, okay? We've talked about the vertical line test. Vertical line test tells you if something is a function, and the horizontal line test tells you if something is one-to-one, okay? So if we go back to the graph, we know that this is a parabola that looks like this. And now if we were to draw a horizontal line, you see it touches twice. So instantly it's not one-to-one. So you can either do it using the proof up here, or you can think about the graph and do it that way using the horizontal line test.